Hello all and welcome back to our sessions on finite automata, that is Moore and Mealy machine. In the previous session we have already seen how to design a Moore machine and a Mealy machine. Now in this session we will be continuing with where we left on designing the Mealy machine to change the each occurrence of ABB to ABA. Step number 1 is theory, that is definition of Mealy machine. Step number 2 is logic. So here we will have the associations of A, B, AB and ABB. To find all the occurrences of ABB, we will be using ends in concept instead of contents of our FSM, right? So we will first find all the occurrences of ABB, and after finding each occurrence of ABB, we will replace it with A. Okay, so here in Q2 state where it goes at Q3, instead of printing B, it prints A as the output. And as seen in this table, we can merge QS, Q1 and Q3 states as they have the same transitions and the output symbols associated with these transitions are the same. And since Q1 gets merged with QS, it becomes a start state. So we have three states, Q0, Q1, Q2, and the output symbols associated with these transitions are AB, AB and AA. Now let us see the transition diagram and an example to understand this in a much better way. So we have BA, BB. So as soon as it encounters the last bit of ABB, it will change that bit to A. As in the previous session we had discussed, we cannot interchange or change the intermediate bits, but we can change the last bit of any input symbols. Okay. Now we will see the conversions of Moore machine to Mealy machines. We have only one rule that we need to remember: assign the output symbols along with the state to all of its incoming transitions. So here is the solution. We will see an example and understand what do we mean by associating or assigning output symbols along with the state to all of its incoming transitions. Now here, as we can observe, we have four states, that is Q0, Q1, Q2 and Q3. So we will just simply go right. So we will have Q0, Q1, Q2 and Q3 states. Now the start state will remain the same, only we have to go on assigning the output symbols to all of its incoming transitions. Okay, so Q0 has three incoming transitions. One is a self loop, so we will assign A. Another is from Q3, so we will assign A. Another is from Q1 over 0 and we will assign A. Now let's talk about Q1 state. We have one incoming transition from Q0. The output symbol associated with Q1 was B, so we will assign 1/B. Another incoming transition is from Q2, so we will assign 0/B to that transition. Now let's come back to Q2 state. So here we have only one incoming transition, which is over 1, so we will assign C as the output symbol, as Q2 has C associated with it. Last but not the least, Q3 state. So we will just simply go on assigning A to all of its incoming transition, which is one is a self loop and another is from Q2. So this is how we convert a Moore machine to Mealy machine, by assigning the output symbol associated with each state to its incoming transitions. Now let us see how to convert a Mealy machine to Moore machine. So here we have three rules that we need to remember. First rule says, if the output symbols along with the incoming are same, then assign that symbol to that state. If the output symbol is not same, then split the states in the number of output symbols that are incoming to that state. And lastly, if there are no incoming transitions, then any output symbol can be assigned to that state. Okay, so let us understand this concept with an example. So here is the question. We have five states, Q0 to Q5. We will write them down one by one. Since we have to assign each output symbol to each state, we cannot write down all these states at one time. So here, since there are no incoming transitions to Q0 state as it is our start state, we will assign N, that is any output symbol to that state. So I will assign N. You can assign any output symbol to this state. Now let us check how many states have the incoming transitions and the output symbols as same. We have Q1 which has N and N from Q0 and Q2 state. right? Q2 also has Y and Y as the incoming transitions output symbol, right, associated with them. So we can write or assign Q1 with N and Q2 with Y, as both the incoming transitions have the same output symbols associated with them, and this will be the transitions that we have to complete. So this is 1, then from Q2 to Q1 and Q1 to Q2 over 1, and this will be over 1. Now when we talk about Q3 and Q4 states, there are different output symbols associated with the incoming transitions to these states. So we have to split them, since there are only 2 output symbols that we are dealing with and incoming transitions are also of that sort. So we will rename these states as Q3N, representing the or associated with output symbol N, and Q3Y, the output symbol associated is Y. Similarly, we will split up Q4N, okay, output symbol N, and Q4YY, output symbol Y, right? Now, when we have to assign the transitions, so in this case, what is going to happen is, this transition from Q1 to Q3 has N associated with it. So from Q1, we will go to Q3NN only. We will not go to Q3YY, because we do not want output Y to get printed when it transits from Q1 to Q3. It is only having N as the output association. Okay. Now next one is from Q4. Q4, that too, next is, we will first complete Q3, then we will come back to Q4. Okay, so from Q3 we have a self loop over 0/Y. So from Q3NN we will go to Q3YY over 0 and a self loop in Q3YY over 0. Since the output symbol is only Y that we are dealing with, we will not have any self loop over Q3NN. Okay, and no incoming transition from Q3YY to Q3NN. Okay, since the output symbol associated with the incoming transition, the self loop of Q3 is Y, we will not have a self loop on Q3NN, okay, but we will have the transition from Q3NN to Q3YY. Okay, now coming back to Q4, we know that we have a self loop over N, so we will apply that self loop, okay, over 1. Then we have an incoming transition from Q2 to Q4 over Y. So from Q2 we will transit to Q4YY over 0. Okay. Now we have to connect Q3 and Q4 carefully. Also we are left with Q4YY over 1, since this is the completion of self loop. Okay. So self loop and other states. Now when we have to transit from Q4 to Q3, okay. So from Q4 to Q3 we have to transit over Y. So from Q4, both Q4 states will go to Q3YY, okay. Both will go to Q3YY over 0. They will not go to Q3NN, but they will only transit to Q3YY, but from both Q4 splitted states. Okay. Similarly, from Q3 we have to transit to Q4, but it is over N. Okay. So this will transit from Q3. Both the states will transit to Q4NN over 0. Over 1. Okay. Right. So this is how we will be converting our Moore machine to Mealy machine. Mealy machine to Moore machine. I'll just rename this transition once. Okay, so this is over 1. Okay, in case you still have any confusion, you can just replay this entire section, and if you have any doubts or any queries, you can leave it in comment section. Okay, and I'll get it resolved in the next session. We will quickly go through some of the applications of finite automata. There are 2 applications of finite automata. One is lexical analyzer, which is one of the phases of compiler, and another is searching using regular expressions in text editors. Okay, So in lexical analyzer, we have to perform some compilation steps or phases. So here we just need to convert our given input into set of tokens. Okay, so here is an example. We have R is equal to letter dot letters or digit. So for example, when we write any variables for any programming language, we know that we cannot start with an special character or digit. So this will be our variable, a data type, and the variable name has to start with an letter as mentioned in this regular expression. So say A. Now A can be followed by either any alphabet or any digit, that doesn't matter, but it should always start with an alphabet. Now this alphabet can be a combination of capital A to Z or small a to Z, right? So this can be recognized using the finite automata such as the NFAs and DFAs. Next is searching using regular expressions in text editors. Many OS have search utilities, correct? So we use the search command to find any word or any text in a given document. We use search utility. So in today's session, if you have any doubts or any queries, you can leave it in comment section and we can get it resolved in the next session. So see you then.